Hey guys, my name's Brandon and welcome to Finance. So in this video we're going to be talking about multiple regression. So in my last video we talked about linear regression, and that is when we had one dependent variable acting on our data set. And in multiple regression it's basically the same thing, only now we have multiple dependent variables acting on our independent variable. So just to go over a few things and catch up. So remember why this is going to be our independent variable. This is the thing that we're looking for. Beta 0, you'll notice is slightly different from the notation in linear regression. And if you go back to my previous video, you'll see this. Beta 0 here, though, is going to be the intercept. So the y-axis intercept. And beta 1, x1, beta 2, x2, etc. They are going to be our dependent variables. Now these will change, so you could have more dependent variables depending on your data set. So however many variables you're testing. And remember, this is the population line. So the population line essentially means that you're testing the data set for everything. And we know that we can't do that. It's impossible to test an entire population because it costs a lot of money, too many resources, and it would take a lot of time. So we are going to use the sample line, which is similar notation, just has a little hat over it, and just be wary of that and remember that this is the sample line. So let's look at an example of how multiple regression can be found. So you own a car and plan to advertise worldwide. You want to examine if there's a relationship between how many adverts you run, friend recommendations, and staff training hours on the amount of car sales you receive. As such, you collect the following data. How would you test this? Well, first thing to point out is there are 3 dependent variables, and these are going to be adverts you run, friend recommendations, and staff training hours. If you remember in the previous example, the previous video on linear regression, this is the same exact example, only we were just testing if the adverts affected car sales. And you can see this in my previous video. So, like I said, there's going to be 3 dependent variables, and here they are. So let's have a deeper look at this. So in my previous video, we went on and talked about linear regression and how we found the tables I'm going to be showing you. So just to give you a quick overview of how I got these tables, it's going to be downloading the data analysis toolkit from Excel, and then simply following these steps that were in my linear regression video in order to produce these tables. They're very easy, and I go into a fair amount of detail on how to find these tables in my previous video, so just have a look there. So a few things I want to point out is that in multiple regression, we're going to be looking at a few different statistics. The first statistic we're going to be looking at that's different is the adjusted R squared. Now, if you remember linear regression, we looked at the R squared. However, the R squared alone is not good enough when you have multiple dependent variables. And this is because if you remember from my previous video, that the R squared tells you how well your best fit line fits that data. And when you add multiple dependent variables, your R squared will always increase. So you always know it's going to increase the more variables you have. So it's not really a good estimator. Therefore, we use the adjusted R squared, which accounts for this. And in this case, we see that it's 0.46, so 46% of our data can be explained by our best fit line. The second statistic we're going to look at is going to be the S statistic right here. And I won't go on how to calculate this. It's fairly simple, but let Excel do the work for you. And that gives us a statistic of 6.41. And one of the important bits right here is the significance F. So significance F is basically just a fancy version of the p-value. And so we have a p-value, and that basically tells us, well, we know we're going to be testing something, so we're going to have to do a hypothesis test. And what this significance F is testing is that it's saying at least one dependent variable is either going to be useful or not useful in predicting our independent variable. So either one of those 3 dependent variables, adverts, friend recommendations, or training hours, is useful in predicting the amount of car sales. And we'll see how we use this in a second. So before we begin, we're going to be going over on how to calculate a hypothesis. If you don't know how to find a hypothesis, don't worry, I have a video for that, so go and check that out. It'll go over how to create a hypothesis and how we find the steps that we're going to do just here in a moment. So if you remember correctly from the previous slide, that 6.41 and the significance f of 0.00 is basically what we're going to be looking at right here. So our hypothesis, the null hypothesis is going to be beta 1 is equal to beta 2 is equal to beta 3 is equal to 0. Now when we say it's equal to 0, we're basically saying that our betas are useless in predicting the model. So we're saying that none of these betas are useful in predicting the amount of car sales. Now our alternative hypothesis is just the opposite. So again, beta 1 is equal to beta 2 is equal to beta 3 doesn't equal 0. So remember, doesn't equal 0. Now we're saying that at least one of these betas is going to be useful in predicting the amount of car sales. So step 2 of our hypothesis generation is to determine the test statistics. So 6.41 simply found right there. Significance level, again, you set this. So we're going to do 95% confidence interval, so 0.05. Step 4 is going to be looking at the significance f. So basically, just like I said, a fancy p-value, and we get 0.00. And if you remember, when we're talking about p-values, if this value in this box right here in step 4 is less than your significance level, so 0.00 is less than 0.05, then you lose your null hypothesis and accept your alternative hypothesis. And now let's put this into some words, and we're going to get something that looks like this. So therefore, with degrees of freedom equal to 19, f statistic of 6.41, and a significance f of 0.00, at least one of these regressors is useful in predicting the amount of car sales when using a significance level of 5%. Make sure you write a hypothesis that covers all that. So give the degrees of freedoms, the f statistic, the significance f, and the confidence level that you're using. So you'll notice once you've done that analysis that you're going to get a third chart or a third table, and it's going to look something like this. And basically what this table is telling us is it gives us the information for our sample line. Do you remember our sample line looks something like this? We're saying that our y variable, so our independent variable, is equal to an intercept of beta 0 plus beta 1 times by x1 plus beta 2 times by x2 plus beta 3 times by x3 plus our error term, which again will always cancel out. And in this case, we're saying car sales is going to have an intercept of 166.58, a adverse slope line of 0.47, a friend recommendation slope line of minus 0.13, and a negative 4.03 slope line for training hours. So I got these numbers by looking at the coefficient box right here, and this is going to give you the equation of the line. So basically, if we just plugged some variables into this line right here, so say we had 300 there, 200 there, and 10 there. That will tell us how many car sales we would be predicted to receive by using this line. Another cool thing we could look at in this chart is we could see how useful each individual dependent variable is in predicting our model. And that's simply done by looking at your t-stats and your p-values. And again, we're going to have to run a hypothesis. So let's run a hypothesis to see if adverts is going to be useful in this model. So step 1, our null hypothesis is going to be beta x, so in this case beta 1, is equal to 0. And if you remember what I said in the previous slide, if it's equal to 0, it means it's useless. It's not useful. Our alternative hypothesis is going to be the opposite. Beta 1 doesn't equal 0. Our test statistic for this is going to be 4.08. Our significance level, again, you set that, is going to be 0.05. And if you look right here, our p-value is going to be 0.00, probably 0.000. And that tells us that we are going to reject the null hypothesis and accept the alternative hypothesis. Again, we'll write something like this. Therefore, with degrees of freedom of 19, a t-stat of 4.08, and a p-value of 0.00, adverts is useful in predicting the amount of car sales when using a significance level of 5%. And you'll notice keeping all parameters constant. So if you change any information, so you change the amount of friend recommendations, training hours, or adverts that you have, you're going to get a completely different chart. So you need to make sure you're keeping all parameters constant. Now, I only did this for adverts, but we could do the same thing for friend recommendations and training hours. And what I'll point out to you here is that if you look at the p-value, it's going to be 0.91 and 0.71 for friend recommendations and training hours respectively. And basically what this tells us is that these two are going to be useless in predicting the model. So again, following the same exact steps we did for adverts, you'll just get a slightly different response. So you would accept the null hypothesis in this case, that they are useless in predicting the model. And one last thing I'll point out here is, how do we improve upon this information? How do we improve our data set? Well, simply, if you wanted to make this better, you'd look at your p-values and you would determine which is the highest. So in this case, friend recommendations is going to be the highest, so it's the least significant in this model. And you could remove friend recommendations and run a new hypothesis and a new test and see if the p-value for training hours and adverts improve or stay the same. And if they do, then you ultimately have a better model. And like I said, we're going to be removing the one that has the highest p-value. So again, that would be friend recommendations in this case. Hey guys, as always, thank you for listening. I hope this was helpful. If you have any questions or want me to go over something in a little bit more detail, please leave me a question. And while you're there, feel free to give me a like and subscribe.